So I'm going to tweak this question out of the textbook a little bit to help you answer the question about when do we reject HO and when not. So the first thing makes sense is what is HO and HA? So from the book, we say, let's see, the people at FizzyPop claim the mean volume of their mean volume of fluid in their 12-ounce cans is 12 ounces. So we're going to make that be the null hypothesis. We're going to say HO, yeah, the mean amount of soda or whatever it is, soda, I guess, in these cans is 12 ounces. And that's going to be the claim. That's what they're claiming. So HA or H1 will be that that's false. Now, we don't know whether it's a right-tailed, left-tailed, like too much, too little. We're just going to say not equal to. So in that case, that's a two-tailed test. Okay. Um, Then what happens if we reject HO? So we go do the test, we find we get a small enough p-value where it's in the critical region. That tells me if the chance of this happening is unusual enough. So usually, now of course they don't tell us the level of significance. If they said if the level of significance was 0.1 or 0.05 is a more common one, and 0.01 is another common one. That's what you need to know. You need what is your acceptable risk in being wrong. In other words, what's your type 1 error risk? You know, you want to say, see, a type 1 error says I'm going to reject HO when I shouldn't. Means this would be, in this case, it would be that the amount of fluid in these cans is not equal to 12 ounces, because that's what HO says, and that's also the claim. So so you have to be given one of these or decide on one. And if they don't give you one, and some of the stuff that I'll have on MyOpenMath, or if you do with that, some of the cookbook problems, I don't tell you level of significance. I read somewhere that if somebody's going to die or lose a lot of money, if you make the wrong decision, go with alpha equals 0.01. If that's not the case, 0.05 is sufficient. 0.1 is a pretty big level of significance. You don't usually see that outside of a textbook. Okay, so what would happen is if I got a p-value, let's say I'm going to go now. This company would lose a lot of money if we said that their cans are not holding the right amounts. We're probably going to go with a 0.01 level of significance, and if our p-value was 0.05, let's make something up, 439, that's the probability of being wrong, um, or the probability that the sample result was that far enough away from 12 to say something was unusual, and we're using this as the unusual cutoff. Well, that's not unusual, so we would fail to reject HO in this case because the p-value is bigger than our level of significance. Okay, and now in this case we'd say the data supports the claim that the mean amount of soda is 12 ounces. Okay, and see why it's important to write which one's the claim. It helps you decide what verbiage to use. Let me pause this recording and go to B. Okay, then for B it says a group of scientists claim the mean daily flow rate from the damaged deep horizon well, that's getting to be a long time ago, is more than 40,000. So the British Petroleum would like to say, no, the mean amount of oil that's being lost is no more than 40,000 or less than 40,000 barrels per day. Barrels, what is it, BBLPD? I don't know, per day. And then, of course, the scientists are claiming that it's more than that. So H1 or HA, the mean is greater than 40,000. So that's a right-tailed test. So see how that's the claim? That's the group of scientists' claim. And then again, if we reject HO, so let's say a lot of marine life's going to be lost if we didn't stop it. Well, that is past. Can't fix that. Let's go with 0.01 again. 0.01 level of significance. Let's pretend the p-value after we run our test, we come up with the p-value, the probability of the sample statistic being that far away from 40,000 is, I don't know, let's go 0.00, 3, 2. So that number is smaller than our level of significance, so we're going to reject HO and say that the data supports the claim that the mean flow rate of oil mean daily flow rate is greater than 40,000. Okay, so to see how really whether we reject HO or not is all based on the level of significance. You take whether you're using the z-score or using the p-value, you always compare it to what is the acceptable risk, and you make that decision. And Dr. Stevens trying to be funny with this one. I claim that most people have a strong dislike of statistics. Well, most people is 50%, right? Or more than 50%. So we'll say HO instead of by proportion because we don't have any kind of average thing. So we'll say, no, that's not the case. Most people don't have a problem with statistics. It's equal to 1/2 or less than 1/2. And H1 would be that this would be the claim. P is greater than 0.5, and that is the claim. And again, if our p-value is small enough, not this p, remember that's the population proportion we're using. We're talking about the p-value and the level of significance. I don't think people will lose money if this is the case, so we'll go with a 0.05 level of significance. And if our p-value from our test, remember that's the tail area. And again, I would call this a right-tailed test. I mean, without looking at any kind of sample results, it's kind of hard to say. But so let's say the p-value is 0.05478, bigger than the level of significance. We fail to reject HO. Okay. So this is a problem from the textbook. One of the ones that doesn't have that you worked out the solution. So I thought it'd be a good one to do for this week to give you an application of rejecting HO and H1. So what they're telling us is that they did a sample of 50 people, and 10 of them had pinworms, and they said the CDC reports that the average U.S. infection rate is 12%. So they want to test the claim that the people of Sludge County have a higher infection rate than the national average. So that tells me, remember, HO was always a statement of no difference, and we got to talking about a proportion here. So we can say, no, the people of Sludge, the proportion of people in Sludge County who have pinworms is no different than the national average. Okay, but the claim is saying that there's a greater infection rate. So what we'll do is we'll do that down here, make it a right-tailed test. And this is actually the claim that we're testing, okay? Now we could certainly run the test, so we need a test statistic and a p-value. And we could certainly do this with z-scores, calculating the mean and all that. But unfortunately, that Rossmann chance output does a lot for us. So get a minute here. I ran that separately, and I'll pull it into here. So in the applet, I had to make sure you select one proportion, because this is about one proportions. And if it's in chapter 9 stuff, you're selecting two proportions or two means, depending on what you're doing. And you have to put in your sample results, right? That's what the sample said. And click calculate, and then you got to set your hypotheses. This is why it's always, I think it's good practice to go ahead and write the hypotheses and symbols on paper. That way, when you come to the app, it's really easy to use. Remember, click, if you haven't been using this much, click on that little button there and make it to be whether it's a right-tailed, left-tailed, or two-tailed test. And then it'll tell you the test statistic, it'll tell you the p-value. Okay, so let's see if I can remember these here. Maybe it'll shrink up, but we can still see it enough. So they want us to test the claim using a 5% level of here, a 5% level of significance. Well, is this p-value less than 5%? It is. So because it is, we're going to reject HO in this case situation. This is really what you'd asked me originally is, how do I know whether to reject HO or not? Well, p-value is less than the level of significance. We'll reject HO. The data supports the claim that the Sludge County has a higher infection rate. But then they change gears and they say, what if you use the 1% level of significance? Well, our p-value isn't that small. Our p-value was what? Was 0.04. So yeah, that's not small enough. We're going to fail to reject HO. See how it's just based on the p-value? Or if you're using level of significance in the classical method there, when you come up with a rejection region. But it's the same thing. It's not in the rejection region. So we would fail to reject HO for B. And why are they making apparently contradictory statements here? How do I get a pointer? Well, that's just because we changed our level of significance. More risk of making a wrong decision with a 0.05% level of significance. Okay? So I hope this answers your question about when do we reject HO and when do we fail to reject HO. Please don't ever say that we accept HA, okay? Because it could be that we had a bad sample that isn't representative of the population. This happened in the 2020 presidential election exit polls. Everybody was coming out of the poll saying, "Yeah, I voted for Biden. I voted for Biden. I voted Democrat." But the people that voted for Trump, conservative candidates, tended not to respond. They denied responding. So the sample they were getting was a bad sample. It wasn't representative of the true population. So since you never know when that's going to happen, we never say we accept anything. We just say that there's data to support rejecting HO, or there's not enough data to reject it. Okay, so hopefully this helps answer your question and gives you the help you need.